Hello everyone. As part of learning generative AI, today we are going to learn transformer and self-attention. What exactly is a transformer? The transformer is a deep learning model which is designed for sequence modeling tasks such as natural language processing, and you are not relying on RNNs and LSTMs because of their shortcomings to process the sequence to sequence, right? And in a paper it was introduced like attention captures the relationships between various elements in an input sequence. The paper is Attention is All You Need. What are the key components of a transformer? Encoder, which consists of multiple layers, and each layer applies self-attention followed by feed-forward neural networks. And the encoder processes the input sequence and generates the rich representation of those input tokens. The decoder, this also has multiple layers, and again every layer of a decoder also uses self-attention, and it will try to process the output sequence and encoder decoder attention method to focus on relevant parts of the input. In the previous session we have seen how the encoder decoder attention is trying to focus which input tokens are to be considered, which are not. Self-attention, the core mechanism which allows each token in input sequence to attend every other token, and it will try to identify the dependencies between various tokens of an input screen, and this entire identification of dependencies happens in a single step irrespective of the size of the input sequence, because of which the transformers are highly efficient while processing long sequences of input sequences. Self-attention mechanism. In this, each token in the sequence interacts with every other token to determine its importance. For each token, a weighted sum of all other token representations is calculated with weights determined by the similarity between tokens. How do I identify these similarities? Using the vector dot product and scalar product calculations. This enables the model to capture short and long range dependencies in the input sequences efficiently. Say for example, I have to translate a sentence, I am eating an apple, right? I am eating an apple. I have 5 tokens in my sentences. So in this sentence, if I have 5 tokens, each token in the sequence interacts with all other 4 tokens of the sentence. And for every token we try to calculate the weighted sum. These weighted sum are trying to help us to identify, are there similar type of words? Do I have 2 subjects, 2 objects, 2 verbs, something like that. So do I have any kind of such similarity between the tokens? We are trying to identify all these things. And this is also enabling us to identify the short and long range dependencies. Say for example, if I am trying to say I am, right? I is not that dependent on am, but whereas am generally comes after I. So you can think of there is a dependency measure carried by am with its previous token I. So you can try to identify the short and long range dependencies between the input sequences. Also, when you are trying to say I am eating, right? Eating is the verb Now immediately the question comes, who is eating? What are they eating? So this eating has dependency with its previous input tokens and its next tokens also. That dependency is how much? So we are going to calculate all these dependencies in one step for all the input tokens. So you are not literally wasting much time in calculating the dependencies. That is how the transformers with self-attention mechanism are taking advantage in processing the longer sequences of inputs. What are the key advantages? Unlike RNNs, transformers can process the tokens in parallel and making the model training very faster. The moment parallel processing is involved, the faster the task will be completed. It is trivial for us. Handling long sequences and the self-attention, as I kept on saying this, the self-attention mechanism is allowing the model to consider relationships across entire sequence in one step. Irrespective of the size of the input sequence, it is trying to do everything, the dependencies, the relationship between various tokens, everything is happening in one single step, making it effective for tasks with long dependencies. And the transformer and its self-attention mechanism are the foundation for various models like BERT and GPT. What are the key characteristics? The transformer architecture. It is composed of encoders and decoders. Sometimes you might have a combination of both. And it comes with a self-attention mechanism which allows the model to attend all the input tokens in a sentence regardless of their distance from each other. Effectively, it is trying to capture the dependencies. What type of dependencies it can identify? It can identify both local and global dependencies. And multi-head attention, which enables the model to attend different parts of the input sequence simultaneously. See, local and global dependencies, whenever you are trying to talk about that, suppose I am trying to say, I am writing my exam paper with my pen which my dad bought, right? So I am using the word my in multiple locations. What could be the dependencies of the first token my with the second occurrence of it and with the third occurrence of it? Does it carry any overall meaning to the sentence or not? So you are going to identify the dependencies of one particular occurrence of a word from the other and one word from the other word, right? Pre-training and fine-tuning. Most of the transformer based models, they work with pre-training combined with fine-tuning. And parallelism, as we kept on learning, the transformers with self-attention mechanism, they go for parallel processing. Thereby what are they trying to do? They are trying to do effective processing of large sequence of inputs. And what are the popular models which we know which are based on the transformer mechanism? First one, the BERT. During natural language processing, you might have worked with BERT. So BERT uses the transformer and it has only encoder part of the transformer, and it is very effective for tasks requiring the context from both the directions. That is the reason it is bidirectional, right? If you see the title itself, you can understand it is using the transformer, it is having only encoder, and it can work with the context from both the directions, bidirectional, BERT. Coming to GPT, generative pre-trained transformer. So it is working with the transformer and it uses only decoder part of the transformer, and it is pre-trained as a causal language model. What do you mean by causal language model? Where the model generates the next word in a sequence based on the previous words. So if you identify the smart compose of mails, when you are trying to compose the mail, it will try to identify what could be the next word when you are typing the mail, right? Causal language model. Highly effective for text generation tasks and open-ended conversations. That is where we are taking advantage of ChatGPT. And the other models, T5, text to text transfer transformer. So that is the reason it is T5. Each word is starting with T. There are 5 words in its name, T5. It's a unified model which frames all the tasks like translation, summarization, classification, everything is text to text. It has both encoder as well as decoder. XLNet, which combines the autoregressive nature of GPT with bidirectionality of BERT. And BART, bidirectional autoregressive transformer. It's a combination of again BERT and GPT, and which uses both encoder and decoder. What are the advantages of this transformer technique if I use the transformer model? First one, scalability. It can process the input sequence which has huge number of parameters. For example, the GPT can process GPT-3 can process the input set or data set with almost 175 billion parameters, which is leading with every possible data set in the world. Flexibility. It can apply to various varieties of NLP tasks, and because of its performance benchmarks, it is giving the state-of-the-art performance. So these transformers generally lay the foundation for natural language processing models, and you are trying to use these models in order to handle complex language tasks without much pain and efforts. Thank you.